Hello, Djordje Romanic here. Welcome to Fundamentals of Weather and Climate playlist. We spent a great deal of time studying dry adiabatic processes in the previous videos. Namely, processes when there are no phase changes of water in the parcel of air. But if you look outside, there are clouds everywhere. These clouds have liquid water, have ice perhaps. So there are phase changes of water in the atmosphere. So how do we account for these phase changes in our thermodynamic analysis of an air parcel moving up and down? That's what we will discuss today. Before we start, please make sure to like and subscribe. I appreciate that a lot. And let me know in the comment section how you are enjoying these videos, if you're enjoying to begin with, and if they are useful for you. So we will start with our setup where we have, let's use black, where we have our two heights. Here is height Z1, Z0 rather, and we have height Z1 that is at higher elevation. And we take this parcel of air, and now we want to bring it to this elevation over here. We know from previous videos, as this parcel of air is going up, it will expand. So if it starts with temperature T0, the temperature at Z1 will be lower. Well, we saw what will happen, namely in dry adiabatic processes. But now we want to look into what happens if we have water vapor, and I'm indicating it with green. And this water vapor condenses and becomes liquid water like so. Now, first question is perhaps when the condensation will happen. We will discuss that in great details later, but you already know that condensation will happen when the partial pressure of water vapor equals saturation pressure of water vapor at a given temperature. My entire playlist on moisture discusses this. Because as the parcel of air is going up, temperature is decreasing. At some point, it will decrease to the value when this partial pressure of water vapor equals saturation pressure of water vapor, and at that point we have condensation. And here, let's say, these green water vapor molecules condensed into these three blue liquid water particles. So, question number one. What is moist adiabatic process? Moist adiabatic process means that when this condensation happens, all heat that is released during this condensation stays in the parcel of air. One more time, very important. What is moist adiabatic process? Moist adiabatic process tells us, okay, you have condensation and there will be release of heat, latent heat of condensation. All that heat stays in the boundary of this parcel of air. Nothing escapes into the ambient atmosphere. Now, what is reversible moist adiabatic process? I told you what is moist adiabatic process. What is reversible moist adiabatic process? Reversible moist adiabatic process is adiabatic process in which these liquid water particles also stayed in this parcel of air. Because you see, when these liquid water particles or ice forms, it can fall out of the parcel of air. Heat can still stay in the parcel of air. Heat that is released stays in the parcel of air, but condensates leave. That is called irreversible process. If the condensates stay inside, that is reversible process. Very important. Why does it matter? Well, if the process is reversible, now I bring this parcel of air down. I bring this parcel of air to where it came from, to Z0. In reversible moist adiabatic process, these three liquid water particles will evaporate and I will get what I started with. But in irreversible process, because in irreversible process these fell down from the parcel of air, when this parcel of air goes down to the original height, there is no more water vapor to, there is no more liquid water to evaporate and become water vapor. So the process is not reversible. I can never get what I started with. This is the main difference between reversible and irreversible moist adiabatic processes. There are other differences as well, because if you remove these condensates from the parcel of air, you decrease the weight of the parcel of air. So the buoyancy of reversible and irreversible moist adiabatic processes are not the same. Another difference is, you see, I told you when this water vapor condenses to form liquid water, heat is released. Yes, heat is released, but still some heat stays in the liquid water particles. Arguably very little, but some. I mean very little compared to the rest of the parcel. So if you are removing condensates, you also remove a little bit of heat, inevitably. That's often negligible, but still it should be mentioned. That's also a difference between reversible and non-reversible moist adiabatic processes. Now, if we write the form of first principle of thermodynamics that we studied, we said that delta Q is equal Cp delta T minus alpha delta P, where alpha is 1 over rho being air density. Everything is defined in my previous videos. We said that the process is adiabatic if delta Q is equal 0. Because in these cases, we have release of heat due to condensation, or if in reversible moist adiabatic process, if this parcel of air is going down, then liquid water will evaporate. That's acquisition of heat. From that point of view, we have delta Q that is not equal 0, and these are not strictly thermodynamically adiabatic processes if we use this form of first principle of thermodynamics. That's why we call them moist adiabatic, because we would say, so to speak, if we exclude this moisture business, everything else is adiabatic. That's a little bit informal way of using first principle of thermodynamics. I'm not going to do it here, that will be in the advanced playlist. One can write the first principle of thermodynamics to have another term, and that another term accounts for phase changes in the parcel of air. And then if you have first principle of thermodynamics written, where you account for change of the composition of your system, of your parcel of air, namely you went from water vapor to liquid water or vice versa, and that term ends up being here. It's a little bit complicated term, and I don't want to write it because this is the fundamental playlist. Then under that more rigorous first principle of thermodynamic, these phase changes are still adiabatic. I hope I didn't confuse you here. If we don't have this term over there, as I don't have it, then this is adiabatic process. If that term is over there, even moist adiabatic processes are purely, in thermodynamic sense, adiabatic. This is a little bit of semantic, and it doesn't matter that much in this fundamental playlist. I wanted to say it because if some of you are pure thermodynamicists, you might dislike the video and say, wait a minute, Professor Romanic, you don't know what you're talking about. I absolutely know what I'm talking about. So, anyways, this is the application of first principle of thermodynamics to moisture in the atmosphere, and what is moist adiabatic process and how it splits into reversible and irreversible moist adiabatic processes. In the next video, we will expand the concept of potential temperature into the concept of equivalent potential temperature, and equivalent potential temperature accounts for these moisture businesses that we have in the parcel affair. Please make sure to like and subscribe. Let me know what you think about Fundamentals playlist, and until next video, goodbye.